Well, hi, good morning, and thanks so much for joining me here in my shop on a rainy, gray June 2nd. And what I'm going to be doing today is looking at a few aspects of the operation of this radio. Going to take some voltage tests, going to consider some of the capacitors that are inside it, some of the old capacitors for replacement, and just plug along with the radio. But first, hey, what's this doing on my bench? So I'm not going to go into detail on this. I am investigating this little guy here. Final coat electromagnetic corrosion protection, the CM3000. It's in my shop here under test. Found this on my car, on my truck. I have a 2013 Terrain, and yesterday I was checking the brake shoes on it, and I noticed this is installed on the vehicle. I almost fell over. This is actually velcroed onto a spot where the air cleaner would be. Well, I don't know what's under the big plastic boxes in my engine anymore, but there it is. So this little guy installed in your car claims to stop corrosion under certain circumstances. This is not a cathodic protection device though. So some of you might react right away and go, oh, it's one of those stupid car cathodic protection devices, but I've discovered it isn't. It works on a somewhat obscure principle of depolarization. I won't say too much more about it. The problem I'm having with investigating this is that I'm extremely skeptical about this, but I have found a scientist's report on it, a serious corrosion engineer with a well-known reputation, a well-known guy, backing this device, or at least backing an experiment demonstrating what this device does. So I'm a little frozen here. I was going to whip off a fast knock it down, throw it away, chuck this scan, and I've come across this paper which I'm studying now. It's a serious paper. So I'm studying this on a serious level. Maybe in a future video I'll expose this thing more. I've done lots of tests. It's pretty interesting. I'm not convinced at all that it can work. Okay, enough of that. Let's look at this radio. So we've tested the tubes, changed one tube that had a short on the grid. Seemed to improve the operation of the radio significantly. We could tell it was working better, receiving stations better after that. Have a weak or a borderline tube at the front here, which we could consider changing out too, but for now I'm not going to do that. I think the next step here that might be of interest is to go through and verify the operating voltages in the radio. In doing that, it's just possible I may find a bad capacitor. But I think the first thing I want to do is experiment with this capacitor here. So this guy, this fairly large one up here, is just verifying it before I say it. Yeah, this side of the capacitor is attached directly to the chassis on a lug down here, along with its parallel resistor. So my understanding is the purpose of this capacitor is to, the way I would put it, drain out any signals that are in the chassis. On another radio I discovered that with this capacitor weak and non-functional, the radio had a fair bit of noise in it. If you touched the chassis, the noise level would increase. I've already tried that little experiment with this radio operating. I don't know if you can comment on it. Touched the chassis, nothing happened. So I'm curious, is that because this capacitor is successfully functioning and draining out what's in the chassis, so injecting more signal doesn't do anything out the speaker? Or is it just something all about the nature of this radio? It's completely different from the other one that I did. So to find this out, and without incurring unnecessary extra work, I would like to disable this capacitor and see what happens in the radio. Now, just looking where this wire goes here. It just goes here. So, and if I could, I would like to leave all this as it is. It looks to be in good shape. Capacitors look to be in good shape. We don't know for sure. You can't tell by looking at them necessarily, but for all the capacitors that I've seen, These ones look pretty good. They look really good. What should we start with? Voltages? Let's start with voltages. Okay, so I'm going to get a little set up for that. Okay, I've got the schematic up on the screen, and we can start from which end? We'll start on the left side at the 12BA6 there. I guess I better turn the radio on or we're not going to get anywhere here. Okay. So, just like you maybe, I'm hiding in my shop here, trying not to watch TV these days. And it is tough. So, okay, here we go. Now, we'll start with the 12BA6. I'm going to zoom in there so we can read the pin numbers. There we are. So the first tube is this one up here right at the top. Got a lot of trouble with lighting here. I don't want to overlight the meter. We're on the 150 volt scale. We're looking for voltages around 100 volts or so, I would think. Let's see. It's written on here, isn't it? So I see 78 volts written right there. It's got to be referring to this line. So it might find 78 on pin 6 and something slightly less on pin 5. Pin 6, 78 volts. Let's try it. Okay, so we'll go 7, 6. It's just, you know what? It's just a little too dark in here for me to work safely. I'm going to blow away my lighting scheme. Oh, you can still see the pointer over here. Good. Okay, number 6. I can see it much clearer right here. Okay, so we're on the 150 volt scale, and on that meter, whoops, that's reading 60 volts. And we're looking for 78, so a little low. So we'll look at the plate on that tube. That's on pin 5. Right next to it, right here. Okay, and what do we get? We get a sleeve. We gotta have a sleeve in the way here. Let's try this. A little bit awkward for me. Don't want to put my finger on the chassis. There we go. That's reading slightly lower than the last reading. That looks like 58 or so. 58, 62. So that's suggesting a bit of a low B+. Let's go right on the B+ down here and see what it is. 110 there, and on the other side, 120. So we have upwards of 120 volts to work with. And so I think there's probably a dropping resistor or something going on here, and it's dropping maybe a little bit too much. Too much for the radio to not operate? 78, 60. 60 is getting pretty low. So if you have the wrong plate voltage, it kind of disturbs the, what can I say, all these element voltages in the tube here, they're kind of all relative to each other. So if one of them is not where it should be, all the rest are no longer appropriate. You could put it that way. How bad? I don't know. Let's carry on. We'll go to the next tube. The next tube is the 12BE6. 84 volts on pin number 5. 12BE6 right here. 85 volts on pin number 5. 1, 2, 3, 4. This is 5. And that's almost 85. Now that's interesting. Oh, what happened there? Is that a tube doing that? Well, I wiggled the tubes, it didn't reoccur. Okay, so we did 5 and we found the correct voltage. Now there's a screen in here on 6. So what I'm doing is I'm wiggling the cans on the IF. I'm moving the tubes around, trying to spot anything that might. Oh, that was interesting. Okay, just make sure the tube's back in. Okay, what was interesting about that was I touched the tube and it popped. So maybe it's still 2-pin problems. So we're going to look at pin number 6 on the 12BE6. This would be 6 here. A little, so same voltage pretty well. Just a little over 80, correct. And this kind of matches the schematic better than the first two. That's kind of interesting. Next two, 12BA6. So pretty much the same thing. 84 and a little more. 84 on pin 5. The 12BA6. That's this tube here. 5, 1, 2. Wow, these look so identical. It'd be easy to get mixed up. Did I get mixed up before? No, very same voltages. Oh, what happened there? Seemed like touching this pin had an effect. So 80 there, a little higher again. Perfect. So touching that stuff is like wiggling the tube a little bit. I don't know where that sound's coming from. Okay. There it is. Maybe we'll be able to figure it out. So keep going. The next tube in the line is 12AT. Oh, that's right. ATAV. We're going to experiment with this at some point. So on the plate of the 12AT, 88 volts less whatever's dropping on this big resistor here. That's a lot. So no more than 88 on pin 7 of the 12AT. 12AT is this one. Pin 7 is way up in here. $52 or $3 on the meter from what I can see. 52 or $3, and it's supposed to be something less than 88. Seems a little low. Okay, there's nothing much else to look at on that tube, just the plate. Carry on now to the output tube. This one's quite critical. A number of things to check on this. We'll start with the plate. So the plate voltage should be pretty much that 120. Okay. 105 here. So you'd expect, 100 up here or something like that, I think. And then this should be am I reading this right? I think I am. This will be a little less because of the 1000 ohms here. So like 195 or something like that. Pin 5, pin 6. 35C5. Kind of buried under all this. Pin number 5. So 1, 2, 3, 4. There it is, way down there. How am I going to get in on that action? I don't know if I'm touching it. Oh, I'm right on the terminal. I'm getting nothing here. Okay, I did something wrong there. 1, I'm counting. 1, 2, 3, 4, 5. That's 5. Well, what have I got something wrong here? 5 on the... Is that not the output tube? Yes, it is. Hard to believe there's nothing on the plate. What's happened? My meter's not connected. Meter's working. So that terminal, there's nothing soldered to that terminal. Oh, what am I doing wrong here? The terminal has nothing on it. Am I not counting these right? Sure I am. Well, 5 and 6. Okay. I don't get it. Something funny is going on. I can't count. 1, 2, 3, 4, 5 has nothing connected to it, and 6. 6 is also very hard to get to. There. Okay, so there's 6 with 80 something volts on it. I must be just seeing it wrong. There has to be something hooked up to 5. Oh man. This is a job for the close-up camera. Let's switch to that. Okay, so this is the last tube in the string. This is the rectifier tube. And this is the output tube. Very hard to see in there. Okay, now pin counting. Oh boy. So the gap, that pin with the big blob of solder, the gap is just below it. That's pin number 1. And then I can see 2, 3, 4, 5. There's 5. And you see the terminal for 5, there's nothing soldered to it at all. What am I doing here? Wow, I'm really stuck. Something is lodged in my head that shouldn't be there. I don't know. Let's take a look at the schematic again here. $35C5. This 5 has to be for this. 6 has to be for that. But I see 5 with no connection. Wait a minute. 5 is the plate? What is going on here? How can this be the case? I think you could regard this as the fun part of doing this work. The fun part of doing this work, where nothing's adding up. Okay, it's just, what are the chances that the pin numbers are wrong on the schematic? 35C5. The chances are so low, but I'm so desperate here to find something. 35. What am I saying now? 35C5. C5. 35C5. On a 35C5, the plate is on 7, and the screen is on 6. And 5 is the grid. 5 or 2, you have your choice here. 35C5. Well, it certainly says 35C5 on the schematic. I'm not crazy. Enjoy the fun, Jim. So we should find a voltage on 7. 7 isn't listed on the schematic. The pin 7. Well, what is on that schematic? Let's go around. So pin 1 is shown. So on the schematic, pin 1 is shown as the suppressor and the cathode. On here, pin 1 is the suppressor and the cathode. Yep, okay. Pin 2 is the signal grid. Keep your eye on the right thing there, Tim. Yeah, so 2 is shown as a signal grid, but they could have used a 5 also if they'd wanted to. But look what they've drawn 5 as the plate. So 3 and 4 are the heaters. 3 and 4 are the heaters, right? 5 is G1, as I've said. 5 is shown as the plate. It's a mistake on the schematic. How many people have been driven around the bend by that mistake? Okay, that's it. I don't like to conclude that someone else made a mistake. I really would rather conclude I'm the guy making the mistake. I feel more comfortable with that, but sure looks that way. Okay, so it's not 5, it's actually 7. Then I would go 6 and 7. 7 being the plate. So 7 is the last pin before the gap. Again, it's a risky guy to get to. Well, the radio is working, so I'm sure there's voltage there. If I go through this way, there's a good chance I'm going to short a couple things. If I come down this way, I think I can get it this way here. There's a lot of things are going to move a bit. There. I saw it go over 100 volts. Okay, so the plate is getting the treatment. Wow. You never know what the challenge is going to be when you're doing this stuff, and the chances of the challenge being an error on the schematic, that's really quite obscure, but I've run into it enough times now that it's actually something worth considering when you get into a really bizarre bind like this. Okay, next thing we want to measure on this tube is the grid voltage. So there is a cathode resistor here, I think. Let's look. So we'll trace the cathode wire. There it is, the 220, and there's the electrolytic across it. So I can measure the voltage drop here and derive the grid voltage, or I can measure it directly, which is what I'd rather do, because this capacitor can be leaking onto this grid. That's the real concern here, that this capacitor is pushing this grid positive from a leak. So let's look at it. We'll get my I would never use the VTVM for this measurement. Use this meter. Use some clip-on leads here. And let's just check these leads. It's pretty good. So it's a little... And not perfect, but good enough. You know what's up. What you want to do here, what am I doing with this meter? I was going to, checking from pin 1 to pin 2. What's the voltage between pin 1 and pin 2? Now, can I possibly get these clipped on? Oh, I can't clip in there. Come on, man. Pin 1. Nah, there's no hope of clipping. To do it with the regular test leads. So if the capacitor protecting the grid on the output tube is leaking some of the B plus onto the grid will go a little bit positive or be less negative than it should be, and the output tube conducts too much current. Okay, so we're trying to read the voltage, which I would expect. Hey, what would you expect? Let's find out what it should be. So 220 sounds like a right-sized. Well, you know what? It's not going to say in here. It's just going to give me the recommended cathode resistors. We'll measure between. Get it right now. 2 and 1. 1 and 2. 1 and 2. That's 1. That's 2. So there you see the grid voltage is about 5. Now is that really what they're aiming for? That seems a little low to me. 5. Okay, well, let's see what the book says. Oh, even though it might not help. This is 35 this way, this way, this way. 35, C5. Maximum ratings. Oh, the maximum plate voltage is only 135. Wow. A screen grid 117. Grid number 2 input. No, that's not what we want. We want grid. Typical operation. Plate voltage 110. Grid number 2 also 110. Grid number 1 minus 7.5. And what did I got minus 4. So it is actually giving a number here. And does it give a resistor? No, it does not. Volts, milliamps, ohms. Nope. 2500 load resistance. Nope. So it doesn't actually give the. That's odd. Usually they give a cathode resistor value in here. Okay, minus 7, and we're only got minus 4. So what that would do is basically the bias is opening a window so it can eat the signal that's coming to the grid without going above the limits. So the bias is kept small, and you feed it a large signal, you'll go above the limit, you'll drive the tube into cutoff or something like that. So you want this big enough that the signal stays within the bias range. Basically, that's the idea. So, you know, we could put the oscilloscope on the output of the radio, right on the speaker, in fact, if we wanted, and see if there's any clipping or anything like that going on. I think we would hear it. So I'm just listening to the static in the radio. I'm going to go after that for a bit. Let's give it a sticking. I'm using extreme precision. No, this is not at high speed. This is me. Just trying to give it the light tap down. Nothing happening. Oh. No, that's coincidental. Give it a little more. So one of the concerns with that kind of crashing sound, it's not quite right, but there can be failures inside the IF transfer. Trying to push right on the tube pins where they're sticking out under here. Not having any luck. So I was saying there can be an inherent problem inside the IF cans themselves, which better known as the silver mica disease, which you can read up on if you like. I'm not sure this is that. Doesn't have quite the right sound. Plus the silver mica disease tends to be kind of continuous. Sounds like lightning. Sounds like a lightning storm far away. Is what it sounds like coming through the speaker. This doesn't quite sound like that. And I have no idea what it is that's doing it. Okay, so we've gone through the voltages. They seem okay. First tube was low. Why don't we look into that? Let's double check first. First tube was measuring low. Try it on this meter. Can anybody recall? Is this pin? 54. I think it was this one. 55. Okay, let's look at the schematic now for that tube and see if we can come up with a reason why it might be a little low. So we have these voltages we're reading here are a little bit low, are getting there through this resistor, 4700, and they're coming on this line, which I think has watts on it. It's the P minus. My eye slipped. My eye slipped. It's this line here. At 88 volts, 105 through the resistor leaves 88. So we should have 88. I can go looking for that now. The 88 shows up here, so we're okay. So if there is something stealing the voltage, it's stealing it from both. It's got to be this guy. So I've got to find this 4700 ohm resistor and consider replacing it. 4700 ohm resistor. Okay. And that's a little bit of a tricky one to find. Boy, that's actually a really tricky one to find. 4700. So what would that be? That would be a purple, yellow, red. Purple, yellow, red. Purple, yellow, red. So I'm looking in here. Where's my stick? So, and it's going to be around the front end too, way up here. Oh man, these aren't. I'm not filling it. Purple, yellow, red. There's yellow, purple, red. You know what? 47. But that's it. That's the right value. It's hooked up to this coil. Oh, I think I'm misinterpreting something here. Yeah, I'm thinking this is an IF coil, just because. It's not. It's an open coil, and I can see it there. I see a 47, and there's a 1000 across it. So here's the 47. There's a big capacitor here, and this is a negative. This is a B minus terminal, so this must be the one on the end of an unnecessarily long wire here. So that would be, now where's the other side go? The other side goes to a pin number 76. Is that correct? Resistor feeding pin 6. Resistor feeding pin 6, yeah. Yeah. So this is definitely the 47. This is the 47. This is the capacitor bypassing it. Can I read the value on it? I don't think so. It's around the other way. It's behind you. Can't see it. So is this really 47? Let's look at the voltage on either side of it. Okay, so like an input-output, if you like. 200. So this would be the output side. Oh! Yeah, I'm on a different tube. How does that work? Because there must be another. It must be another. Okay, wait. Let's work back from the front tube. Front tube. I'm on pin 6 on the front tube here. First tube. Pin 6. Pin 6. Pin 6. Where's this little black wire going here? Oh, okay. Okay, I misinterpreted where this was connected. It is connected here. So that's one side of the resistor. Hopefully, oh, yeah, right. So this is the output side of the resistor, 55 volts, and the input side of the resistor down here, 83. And so the 83, so 83 is correct because it should be 88. That's pretty darn close. And on the other side, it should be 78. But on the other side, it's 54. Okay, power off. Now, can we measure that resistor directly? I think we can, because the top part of the resistor on the schematic there connects to nothing that can leak DC. So I should be able to go right across that resistor with my own meter and read it. Get a little bit of voltage still on it. Let's just be sure. Let's just be sure before we do this. So we're going across this resistor from here to here. Nothing. Good. RU 47K. 4.7 K. 4700. These 5300. That was a strange number I just got there. Let's look at that again. Yeah. 4.34K. 5.34K. Change them out. Raise the B+. I think that's the deal there. So we're going to get rid of this. We're going to change this resistor here. 4700. 4700. How about a nice looking 4700? We have one here. I bought this massive amount of carbon resistors. I almost never use them because almost always they don't have the right size. 47. $4.7K. We got one. Bingo. Okay, 4700. Yellow, purple, red. Yellow, purple, red. No doubt about it. 53. Same reading here. Okay, and let's just double check our 4700. Yeah. That's not much different than 53. There's one. Yellow, purple, red. Let's try this. What's going on here? Some kind of conspiracy? Is my meter inaccurate? Here's another one. I got another one. Yellow, purple, red. Okay, let's use this one. Okay, let's use this one. 4600. How do you like that? I don't normally test those resistors like that. Good thing I did. So we're gonna work this guy in here. The leads are barely long enough. Now, how much can this change the operation of the radio? I don't really know. Can't imagine it's gonna hurt it any. It can only help it a bit. Would it be enough to notice if we test the radio? You know, because I'm not testing it in a really quantitative way, just listening to it, and that might be a little hard to really know for sure. What I said about the volume control. Volume control heals all. Down here. Hope I turned this off. Yes. So on my TV yesterday, I had a choice. I could watch Americans doing one thing, or I could watch Americans doing another thing. I chose to watch the other thing. The space stuff that's going on in the United States is utterly fantastic right now. Someone's at my door.
It's raining.
Yeah. Is it raining hard? It's not supposed to. Okay, let me.
But the stuff is all out on the deck. Are the cats out or in?
They're out.
Oh, jeez.
Okay, cats rescued, no problem. Back to work here. This is usually where I lose track of something. I lost track of my solder. Here it is. Lose track of what I'm doing and then make a mistake. Come on, soldering iron. It's with you. Now I'd certainly see a near problem here. I commented on an earlier video about this wire that comes down from this coil. It seems very inappropriate And now I see it's laying up against other wires. It's ready to short. I'm going to move it out here. I can easily bump that into a short there. Really easily. Okay. Now we're ready to test the radio. Check the voltage, see if it made any difference. And then listen to the radio. See if that made any difference. And then I think I can declare the radio to be voltage safe, or can I? Because we still have that grid that's a wee bit low. So on the output tube grid that's not got quite the voltage on it, we'll assume it's an ever so slight leak through the capacitor that's protecting it, and that'll be one of the capacitors I'll go after. Let's check the voltage here. So I probably leave this video doing these voltage checks and change that resistor. That's the end of that. And in the next video we'll go after these capacitors a little bit. So to check the voltage, we need to turn it on. Okay, made a little change. So we'll turn on with dim bulbs, no problem. Very good. Now we'll check this meter here. We'll use this one. Still on the 150 scale, B minus on the negative, either side of that resistor. Okay, so where's the sound? Here it comes. Okay, on the input side, just over 80 volts. It's still climbing ever so slightly, just over 80. And on the output side, 71. 71's a lot more than 54, and we were trying to get to 78, weren't we? Yeah, 78. So everything just a little bit low, but I think that's much better. Will it have made a difference? Let's find out. Take this down. Okay, radio. What can you do? Oh, here it is. So notice the French station comes in when this string is vertical there. I think that might be a little bit better. Now we're having trouble with these trimmers here being open. They want to come open all the way and don't show a peak. Has that changed? No. And this one had a peak. No. Still doesn't seem to be peaking either the antenna or the intermediate stage. Reception's, I think the reception's better. Let's. So this is a fairly difficult station to get. Most radios can pick this up, some can't. And that's just about as good as it gets. Sitting in my shop here with no help. So I think that's 740. That's 680. Uh-oh. I think I got them wrong. So that's probably 590. It's a very shrill sound to it. So the capacitor's not making, I mean, I'm at the low end here. There's a lot of capacitance in the capacitor, so the trimmer's not I'm not going to do too much. That's a dangerous game I play there.
Problem. So Queen Street is down between Parliament and River for a fire investigation, and also in-town problems on the go at Islington and Rexdale Boulevard. Leon's mega sale is on. Savings throughout the showroom on furniture, mattresses, and appliances.
Good deep no.
I'm Richard Martin with Global News Radio, 640 Toronto, Chopper Traffic.
640.
Lost your job? Make sure your severance is paid.
That's 680. The radio's performance is really quite good. Sometimes for these radios I introduce a boosted signal by attaching this coil to my outdoor antenna, which I think I'll do now that I've mentioned it. Let's do it for fun. And what this does is it allows the power of my outdoor antenna to be impressed onto the antenna of the radio. I have to get these fairly close together, and this extremely awkward, ridiculous arrangement I have here. Okay, now I got to run. Did I turn this off? Yeah, I have to run and turn on that antenna. Direct my outdoor antenna down here to my shop. That's what I have to do. So we'll just lift this more up. I will run and do that now. Okay, since I was out of the room, I really didn't. Okay. So what I'm doing here is I'm causing most of this to resonate at the frequency we're tuned to by turning this capacitor here. Go up to the French station here. I'll tune my antenna. Would seem that most that comes with my boost is noise. Not too surprising. Okay, I just wanted to do that because I've done that with so many other radios. I just want to see how this one's reacting. Fact is, this radio is actually working quite well now. By doing this antenna thing, it gives an impression of what this would be like if I took this out of the house, away from all this noise, and played it. It would work more like this. Yeah, Canada uses a fair bit of temporary foreign labor in the summer to help with crops and things like that. Okay, that's really good. Maybe I've hit the end of the road with this radio. Why would I bother changing out all those capacitors? Because I still plan some experiments. And there's one in there I really do want to change. That's the one for the cabinet. See, I touch the cabinet, nothing happens. Let's do the experiment. Let's do it. I'll end the video by doing this experiment. So I want to get this. I'm going to try to cut the lead to this capacitor resistor combination that's attaching the chassis to the B minus. If I cut the lead, the chassis will then be floating. Who knows what might happen? So I'm going to cut it at the top here where I can get at it easy. There we go. Now that is interesting, isn't it? Are you not finding this interesting? Okay, let me just pull that wire away so it doesn't reconnect. Now, if I touch the chassis, nothing happens. Nothing more happens. Now, where'd the station go? So, I think in this radio, some of the front end is connected to the chassis, and I think what I've done is I've discombobulated that by disconnecting this point. I bet you the radio can receive nothing. Notice I did not put money down on that bet. Well, it's not at all what I expected. Not at all. Quick, to the schematic. Why did this give a result different than what I expected? I thought what would happen is after I cut that away, we'd hear more noise in the signal, and if I touched the chassis, there would just be even more noise. But instead, basically the radio stopped operating. So you can see right here, this is the connection to the chassis. This is the connection I cut. I cut this wire right here. So I disconnected indirectly the antenna loop system, the antenna, whatever the heck that is, loop system. Yeah, it's the loop on the back of the radio. I disconnected it from the B minus. This answers a little more of my questions about what is going on here. It also, the bottom of the oscillator coil, is on the chassis that ultimately connected back to B minus this way. That's crazy. But it's a fact. So it could be the oscillator's not even working in this radio. And the evidence of that would be tuning it just doesn't do anything at all. Tuning it does a little bit. I suspect there's no local oscillator in this radio. That would be the case. We can make a quick check of that. Let's make a quick check of that. So I'm going to be using the SDR radio. It's just popped up on the screen there. And we're going to look for any hint of a local oscillator. So I need a little pickup coil here. Pickup coil near the oscillator coil, which I believe is this one right here. Okay, we'll hang it like that. It's a little ways from it. We'll turn on the SDR radio. And the frequency we're interested in is way down. Way down here somewhere. Depends where the radio is tuned. Okay, now the radio is tuned maybe around 800 or 900. So that would be 455 on top of 913, somewhere around 13 or 14. So you see something big there at 12. On the SDR, that's right here. Let's see. tune it a little bit. So that's got to be the local oscillator. Proof of that would be tune the radio to so the string is vertical here. That makes it about 860. Supposing 860, that should put the local oscillator at 860 plus 455, 12, 1300 roughly. And that's where it is, right around 1300. So it hasn't killed off the local oscillator. Let me temporarily reconnect this capacitor and see if the oscillator frequency jumps around a bit. So very surprising result to me. Now, how to connect those two together without causing a short circuit. I shouldn't have. We can do it with a clip lead, a big long clip lead. Let's try it. Okay, capacitor first. Gotta make sure these clip leads aren't going to go somewhere as soon as you take your eye off them. Okay, question is, does the local oscillator jump around? So it's right here. Keep an eye on it. Actually, if you look at the waterfall display, you'll see if it jumps. Yep, it jumped. Let me put it back up. Hey, it's picking up the radio station. Not much, jumped a little bit. So what that would tell me too is, let me get this off here now. So I've done a preliminary alignment, and most of the time I'm thinking most of these components don't really affect the alignment very much, but I don't know for sure if that's true. This one does. This one will throw the oscillator off because I'm lifting the ground from the bottom of that oscillator circuit. Very good. Okay, exciting stuff. That's the end of that. That's the end of today. That's some good stuff. Enjoyed that. And tomorrow we'll take a close look at all these capacitors and make decisions on them about changing them out or not. The radio's working quite well. And even the one I disconnected here, for all intents and purposes, seems to be okay. Okay, that's enough. I'm going to go enjoy my day. You do the same. Stay away from the TV set. See ya.